Okay, so positive forward acceleration when applying the brake. What do we think? What if our bicycle was on a hill? Okay, so we have our bicycle on a hill, and naturally, without pedaling it forward, that bicycle would want to roll down the hill, right? And so I would say that's my negative direction, and that's my positive direction. So if we're not pedaling and the bicycle is being pulled down the hill, and then we apply our brake, because initially we'd have this negative velocity, right? It's going in the negative direction. And we apply the brake, well, that slows the bicycle and makes it come to a stop. And so that must mean that that brake is providing a positive acceleration. Okay, now I want you to take a moment and realize that these positives and negatives, they're the direction component here. That's what we mean by positive velocity or negative acceleration. We're talking about the direction in which that's being applied. Okay, so how can you have a negative acceleration without braking? Negative acceleration without braking. Well, what if, back to our situation with the hill, we are riding our bicycle down this hill, and we don't apply the brake, but we're speeding up. And we're speeding up because our acceleration is negative as well as our velocity is negative and our acceleration is negative, and that's causing us to speed up as we go down this hill. All right, let's look at a couple practice problems. Okay. So, let's make this. A ball rolls up a slanted driveway. The ball starts at 2.5 meters per second, slows for 5 seconds, stops for an instant, and then rolls back down the driveway at an increasing speed. So the first thing we're needing to do is sketch the problem. Okay, so sorry for the sun glare here. We have our incline. We have a ball, let's say the bottom of our driveway here, we're going to call that our 0, 0, our origin. And we're going with some initial positive velocity of 2.50 meters per second up this incline. And then after a time period of 5 seconds, we've reached some maximum displacement where we come to a stop before the ball then starts rolling back down the incline. And so I would say my velocity here at the top in this moment right before it starts rolling back down the incline is 0. Okay, so I see an initial velocity, I see a final velocity, and I see a final time. This all occurred in 5 seconds. Okay, so I sketched the problem. I chose an origin, and I said this is going to be my 0, 0, and I'm going to call this my positive direction, and this is going to be my negative direction. What is the sign? So I'm looking right here. What is the sign of the ball's acceleration as it rolls up the driveway? Okay, so we know as it rolled up the driveway, it slowed down and it came to a stop. We also know that the initial velocity of the object is positive. We have a positive 2.50 meters per second. And so if we had a positive acceleration, it just would have kept speeding up. But a negative acceleration means that the object would slow and eventually come to a stop. Okay, so that's how we know that the sign of the acceleration of the ball rolling up the incline is a negative acceleration. And then we have, what is the magnitude of the ball's acceleration as it rolls up the driveway? Okay. Well, Average acceleration is a change in velocity over a change in time. Okay? And delta means final minus initial. So we have velocity final minus velocity initial divided by time final minus time initial. In this situation, my velocity final was 0 when we got to the top of our incline there. And then my initial was the 2.50 meters per second. So minus initial divided by time final, well, this occurred in 5 seconds, minus time initial, well, we started at 0 seconds. Okay, and so acceleration is going to equal negative 2.50 meters per second divided by 5 seconds. Okay, so let's look at units and let's confirm that we do actually end with acceleration here, which is meters per second squared. So we're taking meters per second and we're dividing that by seconds. And then here we can place that over 1 if we want to. This is the same as meters per second multiplied by 1 over seconds, or meters per second squared. So our units all work out. Okay, so we end with negative 0.5. Now we had 3 sig figs, 3 sig figs, and so we want to end with 3 sig figs. Negative 0.5 meters per second squared. Okay, what about the one below this? So a car is coasting backwards down a hill at a speed of 3 meters per second. When the driver gets the engine started, okay, so a car is coasting backwards down a hill at 3 meters per second when the driver gets the engine started. After 2.5 seconds, the car is moving uphill at 4.5 meters per second. If uphill is chosen to be the positive direction, what is the car's average acceleration for this whole interaction here? Okay, so let me see if I can put a book up and block some of this air. Okay. So let's draw a picture. So backwards down the hill. So here's our hill. Here's our vehicle. Okay, so at first, the car is coasting backwards down the hill at a speed. Notice so carefully, we're using the word speed here, not velocity, of 3 meters per second. Okay. And so my velocity initial is actually a negative 3.0 meters per second because this speed is occurring in the negative direction because we're saying down the hill is negative. When the driver gets the engine started after 2.5 seconds, so it coasted down the hill for 2.5 seconds and then it got the engine started, okay? And then after 2.5 seconds, the car is moving uphill at 4.5 meters per second. Okay, so he's coasting down the hill at a negative 3 meters per second. Then starts the engine. Okay, and after 2.5 seconds after getting the engine started, now they're moving up the hill at 4.5 meters per second. Okay, so my velocity final is a positive 4.5 meters per second, and the time in which this occurred, my time final, is 2.5 seconds. Time initial was 0. What is my average acceleration? Don't forget our average velocity equation. Change in velocity over change in time. Velocity final was 4.5 meters per second. Velocity initial, so minus my negative 3.0 meters per second, divided by time final, which is 2.5 seconds, minus time initial, 0 seconds. Okay, so acceleration is equal to 7.5 meters per second divided by 2.5 seconds. And so that gives us 3.0 meters per second squared. Okay, nice. We have a couple more practice problems. I want you to give them a go on your own. But if you're feeling confident and you're like, yes, I'm understanding this acceleration, and I get how direction dictates whether we're a positive or a negative, then go ahead and move on to the assignment. But if you're wanting more practice, then please watch the last final video of our learning target number 4.